It's been considered for many years that transthyretin, TTR, is a transport protein, and that gave it its name. It's the transporter of thyroid hormone, a minority of thyroid hormone, that is T4, in the systemic circulation, and the major transporter of retinol bound to retinol binding protein. So vitamin A transits through the system for the most part through transthyretin. It's very clear that transthyretin is a minor transporter of T4, except perhaps in the embryo, when the presence of transthyretin, it transports it into the brain and allows normal brain development. So it's essentially a transporter protein. That's been its major description. But in fact, there appear to be other functions that we're not fully cognizant of. It appears to play a major role in neuronal response to stress. It may play a role in repair of nerve damage. And there are some papers reporting that it plays a role in the pancreas in signaling. But those roles are much less defined presently than the originally described roles as a carrier protein. But it's now become clear that it is, like many proteins that we thought originally had single purposes, turns out to have multi-purposes. The major deficit in TTR knockout animals, they do not appear to have a defect in thyroid hormone metabolism, but these animals have a defect in spatial learning and spatial differentiation. And if you look at their brains, they are not normal. In the regions of the hippocampus, they show some neuronal loss and they show gliosis. And it's not clear what the basis for this is. There may be some defect in the generation of new neurons from the supraventricular zone. But at the moment, there does not appear to be any analog of that in humans, but it's very difficult to study.